Hello. So today we're going to continue on the energy and we are going to apply the energy method for pendulum. So 钟摆, okay? All right, so pendulum looks like this. Right, so let's say you started with velocity equal to 0 right there. And then you have an angle theta, okay? You let it go, and now you can ask yourself a question when it reached here. So let's say now we have this one here. So this is the h, right? It dropped this much. And let's say that's equal to 1 meter, for example, right? So now we can ask ourselves, what is the velocity, okay, down there? What's that equal to, okay? So then we can use, in this case, we treat Earth as, and this m, okay, the m, say that's equal to 1 kilogram, okay, and the m, a system. So then we can apply conservation of mechanical energy, okay, versus part of system, and only mg is there, and then this is also T right there. So let's look at the free body diagram. So this is the T, right? The tension from this is a rope. Okay, and that's a mass. So this T, and you look at this is the displacement is going this way, right? It's always 90 degrees, okay? So the work done by the T is 0, okay? And then the work done by the conservative force is not 0, but because we are treating Earth as part of the system, so we don't talk about the, the work done by the mg, okay? Because that's already, because this is already embedded inside the potential energy. Okay, so then the only force is T, of course, there's no drag. Then in the W and C equal to delta ME, right? Or delta KE plus delta PE, this is 0, right? So this is due to tension. So then we have this one equal to 0. So then you can then apply MC, ME is equal to constant or conservation of mechanical energy, okay? All right, so then I'm going to change in color here. The color is, then we say this position 1, this is position 2, okay? And we say ME1 is equal to ME2. It's all equal to constant, right? So you can do that. So then you say PE1 plus PE2, not PE2, KE1, it's equal to PE2 plus KE2, okay? And we're going to treat right there, right, the PE at this position, this height, okay? This is the reference right there. That PE at that location is equal to 0, right? So then we can say, all right, this is 0. And then KE1 start with velocity equals 0, so KE1 go away, and that's equal to 0. So now we have PE1, which is mgh, right? This is that. It's equal to 1/2 mv squared. Okay, so then I'm going to change in color here. So they can cancel the m now. So now you can go and find out the velocity is equal to 2gh square root. Okay, so that should not look too unfamiliar. Then you can apply that. So that will be 2 times 10 times 1. So it'll be square root 20. Or you can say this is going to be 2 square root 5, right? Meter per second. Okay, so that's the application of energy method or conservation of mechanical energy in particular into this particular problem, which is a pendulum, okay? Which is a pendulum. We call this a pendulum. Okay, so that's a good place to stop. And we'll see you next time. Hopefully you're learning something fun.